Very good evening, guys. Welcome to the bootcamp webinar on Introduction to Python for Data Science. First and foremost, let me introduce myself. Hello, I am Boni Canute. I am a data science specialist here at FacePulse. For this particular webinar that is basically we'll be initiating in today is kind of going to go in and help you to demystify what data science exactly is and how Python will help you to go in and start up your career in data structure, right? So starting off with this particular webinar, right? We have three main agendas today. We'll be trying to go in and understand the fundamentals of Python because Python is this particular tool. It's a programming language that we're going to be using in. So as to go in and perform certain operations and tasks, which will help us to go in and solve business problems. Right. So I'll be going in and addressing the same point later up ahead as well. Another point we're going to be going in and discussing will be how Python is used for data science and machine learning, as well as data visualization. Now, as I said, data science, right? Data science and machine learning related job profiles at this current point are well sought after. The main reason being they fetch really high income at this point and are high in demand. One of the reasons for that is because the current market right now, lacks skilled employees. Right. So basically, it's kind of expected that data science related firms will be worth over 16 million by the year 2025. And right now, at this point of time, this is the best time to go in and get started with data science such that you can build up a really good career in it. This entire webinar, we'll be going in and splitting it across, five different sections. Altogether, it will be six, but the overall roadmap of this webinar, the way we'll be going in and uh, discussing all of these topics, we'll be following this particular roadmap over here. Okay. So initially, we'll kind of go in and discuss a bit around on what Python exactly is, the entire ecosystem of Python, because Python is a language which has a lot of libraries. To be exact, it has around 2 lakh plus libraries that can be accessed and used depending on whatever your requirement may be. Then we'll be going into data science. We'll be understanding what exactly is data science. We'll be seeing a few use cases and the scope of this particular domain. Then we'll be moving on to seeing the various Python tools that are used for data science, and then data visualization, and then finally followed up with machine learning and its scope with Python. Now, starting on with this, why exactly Python though? Why are we emphasizing this much on Python, right? So, see, Python, pretty much like every other programming language out there, is just meant so that a person can go in and write a code. Sure. But there are certain advantages and functionality that Python provides, which makes it the best candidate or the best programming language out there for the purpose of data science and machine learning. Right. So a long time back, there was a poem written on Python, right? So you may call it a poem, but this is nothing but so there's this documentation that was made. It was called The Zen of Python by Tim Peters. So this particular poem, or you can say this entire paragraph, basically consisted of the 19 guiding principles for writing Python programs. All right. So you can actually read upon this, but I kind of wanted to go in and put up a few lines over here so that we can kind of go and get a pretty good idea on why Python is so highly used. So this is one of those guiding principles, right? Beautiful is better than ugly, and explicit is better than implicit. Simple is better than complex, and complex is better than complicated. I'm pretty sure for any person who's over here who have had a crack at Python, you would have seen how easy it is to go in and write programs in Python. Now, let's say, for example, if I were to go in and write a program in Java just to go in and print a certain sentence. Let's say I want to go in and print hello world. In Java, it would basically go in and take me to create a class. I need to go in and make a main method and then follow it up with that and on, right? So the amount of lines of code that you will have to go in and write depends upon the languages that you go for. And one of the main, key selling points of Python is its usability. You can perform complex tasks without having the need of putting in large number of lines of code. So, we'll kind of be going across a few more points as in such. Let me put up some numbers for you because I may go in and preach everything about Python as much as I can, but facts speak for themselves, right? So till this point, right, till the year 2021, there has been over 5 million downloads of Python just for Windows users alone. We are not considering all those developers who may be using up their Mac or Linux-based systems. Just for Windows users alone, there have been over 5 lakh, sorry, 5 million downloads altogether. Okay. Now, here in this particular scenario, like I did go in and put this, but I did bring in this point as well that Python is a particular language which contains or which is able to use tons and tons of pre-built packages. You can also call them as libraries, if you please. But the thing is, unlike other languages like Java, let's say, Java also has tons and tons of pre-built libraries that you can use. But unlike those languages, Python has such a diversity and widespread community data, you can say a wide developer community at this point, that there is more than 2 lakh Python packages that you could go in and use. And which also kind of makes it, pretty reasonable on why it's the second most sought after programming languages right after JavaScript. So these are facts that are put in the recent years, and you can kind of see Python has made its mark and it is here to stay. It is a language which has tons and tons of functionality and use cases, and that is why it's so popular. If you say no, where all Python is going to be used, yeah. Now the good thing about Python is it doesn't matter whether you're on Windows, it doesn't matter whether you're on Mac, it doesn't matter whether you're on Linux. It is a programming language which is meant to go in and run across different systems, regardless of whichever operating system you're running, and regardless of whichever processor you have up in your system. You can use Python for basically anything. You can use it for web development, game development. You can also use it for machine learning and artificial intelligence, which is our main point of discussion here. And last but not the least, you will be going in and using it for data science and visualization. So for all of these use cases, you have special libraries that are built for it, right? So we'll be going in and addressing these certain libraries that are part of the Python ecosystem, which will help you to go in and start up your career in data science. Now, how exactly? Now, there might be a few people amongst you right now who would be like, okay, I don't know Python. I want to learn Python, right? See, the thing about learning a programming language is really simple. It's a three-step process, right? I'm not just saying this for Python. It may be any programming language that is out there, right? Be it you want to learn JavaScript, be it you want to learn Java, or whatsoever, no issues. Every single programming language that is out there can be learned in three single steps, right? Now let's kind of think upon this way. Let's say I want to learn French. Okay, I want to learn how to speak French. So the very first thing I'd go in and do is to work on my vocabulary. I need to go in and learn a few set of words, and each word has its own meaning, much like in English. Vocabulary is nothing but all the set of words that you are familiar with, right? Every word having its own meaning. So when I go in and I work upon a vocabulary, I'll be learning a lot of words. Okay, how their pronunciation goes, what their meaning is, and in what context are you supposed to be using them. So let's say if I want to learn French, right? That was the case. So first thing, step number one is to go in and work up on my vocabulary. Now, knowing a few words is not enough because if I want to communicate much more effectively, I need to be able to go in and form proper sentences. Now, this is basically done using something called as grammar. What is grammar? Grammar is a set of rules which basically dictate how should you go in and form a sentence. Subject plus verb plus object, that's basically how you form a sentence. That's a rule that we have in English for forming proper sentences. And then, so I need to first and foremost, step number one should be to work on my vocabulary. Step number two, work on my grammar. And step number three would be basically if I want to get really good at it, I just need to speak. The more I speak that particular language, the better I become at it. Now, the same three process or the same three steps that you need to go in and repeat up for Python, right? If I wanted to learn French, the step number one would be to learn vocabulary. In terms of Python, we have keywords. As of Python 3.10, which is the recent release in the year 2021 of 2021 October, if I'm correct, Python has only 35 keywords. I'm pretty sure remembering 35 keywords and their use cases won't be a difficult thing for us. Pretty sure. It's just 35 words, 35 keywords. Each word has a certain functionality and use case to it. Now, in French or in any spoken language, we'll have grammar. In Python, we have syntax. So once I go in and get acquainted with the various syntaxes that I need to follow so that I can write a valid program, Python program, I'm all good to go. That's all I need. If I want to write a Python code, what all do I need to know? I need to know the keywords and I need to know the syntax. That's it. If I want to get really good at Python, the third step is obviously to go in and code. The more you code, the better you become at it. Now, if you want to go in and get your career started up with that of data science, I'm not saying you should go in and know each and every other thing that is to be known about Python. The basic necessity or the basic requirement that would be there would be the fundamentals of programming in Python, the basic fundamentals, right? So what I mean by this is we'll basically start off with data types. Python has various data types that you can go in and manipulate. If you want to store numeral values, you have integer, you have complex, you have float, right? If you want to go in and store information as a sequence, let's say I want to go in and store a sentence or a word, I have string for it. Let's say I want to go in and store lots of values together, lots of numbers together, or let's say I want to store lots of names or words or sentences together. In those cases, we come across something called as containers.
Like if else statements, if statement, these kind of help you to go in and control the flow of execution of your program. Then we have looping statements, which will help you to go in and iterate over or repeat a few set of instructions over and over again. And then the fifth component that you need to be familiar with if you want to be good at Python would be functions, because Python is a programming language which supports various paradigms or various programming styles. You can use Python to write a procedural program. You can use Python to write a functional program, and you can also use Python to go in and write a program using object-oriented concepts. You can use classes and objects. So this is one such merit or plus point to Python is that depending on whichever programming approach you want to adopt, Python can be used accordingly. You want to write a procedural program, one instruction after another, sure, go for it. You want to write a functional program, divide the program into smaller subsections, each subsection being a small function which can be repeatedly and iteratively called. Sure. Or if at all you want to go in and achieve the advantages of object-oriented programming, you could go in with that as well. So object-oriented programming is going to be a very last concept that you need to be familiar with Python in the fundamentals, because one of the reasons why object-oriented programming plays a really big role is because you will be using lots of packages. Okay, so we'll address this package concept in a minute. Now, yeah, as I was speaking in about sequential data types, right? Python has 4 different containers, as I was saying. So, see, learning, as I said, learning Python is not a difficult thing. Just go in and get acquainted with the various keywords and their corresponding syntaxes. So, Python has basically 4 containers that you can go in and utilize. You need to be really, well aware about these, because you're going to be needing them for computational purposes. When you'll be working around with various Python tools for data science. So we have 4 containers altogether. The very first one being list, tuple, set, and the last one being dictionary. So these are the 4 containers that you get access to in Python. It's pretty simple to remember. Just there are 4 of them: list, tuple, set, and dictionary. All of them are going to be used for storing information, but each of them have their own unique property. Okay. So there is no need for us to go and mug up anything. Okay, now when you think of a list will always contain information in an order, right? So a list will be going in and storing information in a specific sequence. You can store duplicate values in a list, and similarly in that you can also go in and manipulate the list as per your requirement. Now a tuple is exactly similar to that of a list, but the only difference that you come across with that of a tuple and a list is that a tuple is immutable. Immutable in the sense, see, whenever you deal with object-oriented programming, this concept of immutable objects would come into picture. Now, immutable means if an object is said to be immutable, it means that its value cannot be changed. If you create an object, best example, strings. The moment you create a string object, the value that is stored within that string object cannot be changed. That is what we mean by immutable. Alright. Then we have sets. Set is again going to be used to go in and store information, surely, but it has one really important property, and that is that it cannot go in and have duplicates in it. Unlike a list or a tuple where you can put duplicate values, right? A set will not allow you to go in and store duplicate value. If you go in and try insert multiple duplicate values into a set, there will be only one instance of it present in the set at the end of whatever instructions you would have executed. Now, one more property of a set is that it will be unordered. Now, regardless of whichever order you're going to insert the values into, you might not get them in the same order when you print out the values from the set. So, a set is an unordered collection of values. It is mutable, similar to that of a list. Then the last container that we have is called as a dictionary.
Dictionary is what we call as a dictionary basically allows you to go in and store key value pairs. You will be storing information, sure, yes, but every information that you have is going to be stored in pairs of keys and values. So each input, each piece of data will have 2 components in it. It will have a key and its corresponding value. You want to access the value, you need the corresponding key, right? So a dictionary, unless, similar to that of list and tuple, will be ordered. You can go in and store information in a particular sequence. And one more thing to keep in mind is a dictionary, the keys in a dictionary must be unique, compulsorily have to be unique. If you're going in and using duplicate keys in your dictionary, it may happen that you will go in and overwrite a pre-existing key value pair. So make sure whenever you're using in a dictionary, the key and value pair, the keys are kept as unique, and values need not be kept unique. Okay, maybe duplicates, not an issue. All right. So, as I was saying, this is a basic set of concepts that you need to be familiar with. The containers, every single various set of containers, especially data types, as I say, need to be properly studied and practiced upon because if unless and until you are familiar with the basic fundamentals of programming in Python, you will not be able to embark in your journey to go in and start up your career as a data science. All right. Okay. Now, the thing with Python is one really peculiar thing about Python is that everything and anything and everything in Python is an object. Now, it doesn't matter whether it's a variable or it's a container or if it's a function or even just a straight up class, right? Each and every single thing in a Python in Python is an object. Right. So this kind of makes it, well suitable and ideal for developing modular applications that contains multiple modules with each, really unique, properties or functionalities, as I say. Now, let's move on to the second agenda, right? Now, Python is a language, as we saw in earlier, Python is a language which has more than 2 lakh packages supported. Okay, Python supports more than 2 lakh additional packages that you can use. Now, what exactly do we mean by packages? Because you would have heard a lot of people going and saying, yeah, I'm going to use that Python package over here and get it done. Yeah, sure. Okay. What exactly do you mean by package though? All right. See, the concept of package is really simple. A package is nothing but collection of modules. You can have multiple modules in it. What is a package? A package is a collection of modules. Think of it in this way. You have a folder in your desktop right now. Inside of that folder, there are multiple other folders. So a package is basically nothing but this collection of multiple modules that can be used for a certain purpose, right? So a Python, what's a package in Python? A package in Python is nothing but collection of modules. Now a module in turn can go in and have multiple classes and functions present inside of it, right? And the class that we have, right? Because if you're familiar with a bit of object-oriented programming, a class is basically going to consist of data members, which are basically variables, and member functions, which are just, again, nothing but functions. So this is the overall structure of what a package in Python is all about. You have code structured into smaller packages or smaller sections, which we call as modules and packages. All right. So there are tons and tons of Python packages that we can go in and use. There are tons and tons of them, right? One of the most famous Python packages that we have are TensorFlow, which is heavily used in for machine learning purposes. We have Matplotlib, which is used for data visualization. We have Pandas, which is going to be used in again for us in terms of data science. We have another really important library, which is NumPy. We have KRS for machine learning, and at the end, we have PyTorch as well for ML. These are pretty well-known packages across the data science community, I'll say, and you'll find tons and tons of people working on projects which would be dependent on either one of these packages, right? So yeah, so we're going to be using Python for data science. Sure, we just went in and discussed why Python is so good and how exactly should we go in and learn Python. Sure, yes. But let's come down to the point. We are basically here to go in and address data science, right? What exactly is data science? Okay. So, see, rather than going in and giving you a textbook definition of, saying that, yeah, data science is basically nothing but collection, analysis, and providing insight of data. Sure, that is absolutely correct. I'm not saying that's a wrong definition. Let's take a sample scenario and try to understand what exactly data science is and how it is affecting our day-to-day life. Right. So, I'll take a really simple example. Right. I'm pretty sure every single one of us would have used Netflix at some point, right? Netflix is an OTT platform which provides you content to go in and watch. It gives you movies, series, anime, whatever you want. You can watch it on Netflix, right? Now, one thing you would have noticed is, see, every time you go in and you watch a movie, it will go in and start recommending you some other movie to go in and watch. Because, see, the entire business model of Netflix is based upon whether a consumer will go in and pay their subscription fees so as to watch the content that they're providing, right? The content in the sense movies, series, anime, right? These are the content that they're providing. So their business model is completely reliant on this fact that how much is the consumer, the average consumer, going in and using their platform. So what they want is kind of want to go in and give a really good user experience to anyone who would use Netflix, right? So, you might come across this particular slide pretty often, not sure what to watch, right? Then, it will go and you'll get a small button over there. It will be written as play something, right? So the moment you click on that button, based on your preference, based on the movies that you watched, based on the actors that were in it, based on the genre of movies and series that you watch, it will go in and recommend to you certain movies or series or that will be to your liking. And the possibilities that they will be is really high. Why is that so? Because they have information, right? Netflix as a corporation has a lot of information about you, right? Every firm, every product-based company has tons and tons of information about you. All right, I'm not just talking about Meta. Every single company. Netflix knows your credentials, right? Your email ID and what's and not. But another thing it also goes in and knows is what all movies are you watching, for what duration are they watching, what genre movies do you usually prefer, and at what time. Now, you might usually get notifications in your phone, right? You don't just go in and get notification in your phone at any random time. You get it at that specific time when you are most likely to go in and be free. So there is a lot of data that is available which can be collected, processed, and then analyzed so as to give the user a really good experience in using up their application. This is a really good example of how data science is playing a really big role in our day-to-day life. You go in and we go in and we use Gboard or any keyboard that is out there, right? Anytime you go in and you type out a few set of words, right? You have this autocorrect option that basically pops up, right? Again, courtesy of data science. Another really good example would be the mail categorization algorithm, which runs in any mail application. Let's take, for example, Gmail, right? So you have your inbox and the start and send and all of these other sections, but there is also this really particular section that we have, which is called a spam detect, a spam, right? So every time you receive up a mail, the Gmail platform is able to go in and figure out whether that particular mail that you received is actually spam or not. How is it able to do so? Simple. You gather information about all the companies which will go in and send you random mails which have no purpose at all. You go in and you provide enough information. You have enough information, you won half the war. Right. So spam detection, this is one of these areas where data science is, you know, uh, I'll say it is making lives of people pretty simple, I'd say, because if this wasn't the case, your inbox would be cluttered with tons and tons of newsletters and information that are not at all useful, right? So now, here the scenario is, see, now let's kind of try to define what data science exactly is. Now, I did give you guys a straight up definition in the very beginning, but just to reiterate on this, data science is basically all about going in and collecting information, analyzing it, and then providing really crucial insights on how you can go in and solve business problems, right? If you take the same example as that of Netflix, right? Netflix wants their user base to go in and use their platform as much as they can. So how can you go in, how can Netflix go in and make them watch more movies? They recommend it to them. Now, if they go in and randomly recommend anything, it will not work. They need to recommend something which that particular user would like to watch, something which is of his taste, right? So all of this can be easily or is being achieved using data science. Data science is pretty simple. All you do is you collect information, you analyze it, and then you provide important insights of the data that you processed to solve business problems, right? So if we kind of go along with the same example that or the same scenario that I'm trying to paint over here, the entire data science process would somewhat go in and look like this. The very first step is going to be called as collection. You need data, right? It's not like data will go in and just come out of nowhere. You need to collect it from somewhere. Data collection can basically can be done from tons and tons of places. You have social media, which basically sells in information. I'll say you would have heard this entire this theory. I think this was a pretty big news when Meta at that point being called Facebook went in and was able to go in and access really crucial user base information. So, information can be gathered up from a lot of sources, right? And then the second step of the entire data science process would be to go in and clean the unstructured or structured data that you would have gathered. Okay. Now, structured and unstructured data, these are terminologies we'll be discussing up soon in the upcoming sessions that we'll be having from the dates that we'll be announcing in soon, right? So you take this information, be it structured or unstructured information. Now it needs to be uncluttered out because it might happen like from whatever data that you collected, there is unnecessary information or residual information that is present in it. So we need to clean it out, right? So the collection and the cleaning process of the cleaning of the data is taken up by a group of people that we call as data engineers. You might have heard of this profile up a lot. And this is what they do. They are in the entire data science process. Data engineers are mainly solely responsible for going and collecting and cleaning up the information such that they can be processed in further, right? And now, once you have the information, once you have the requisite information and it's not cluttered much, the third step would be to go in and analyze your information, whatever information you'd have had. So that's a third step, which is exploratory data analysis. And this is kind of where data analysts will be coming into the picture, right? Data engineers, data analysts, machine learning engineers, all are part of the data science process, right? So you need to know what exactly does a data engineer do. A data engineer is associated with collecting and cleaning of information. A data analyst will also be involved with cleaning of information, but their main task will be to go in and perform exploratory data analysis. Now, once your data has been analyzed, right? Now you want to go in and uh, you know um, go through all that information and gather insights for it. See, but this is where the problem lies, right? See, in the olden times, the user base and the amount of data that people or companies you had to go in and handle was pretty low, I'll say. Okay, so you can say that I had a firm in the year 2000, let's say. 2000 is a long time back, but let's say I had a firm in the year 2000. So every single piece of information that is related to my firm can be put up in a single spreadsheet, right? But as time passed over the decades, the data that we had, okay, or the amount of data that was being generated out went in and increased exponentially. to the point that we just didn't had data, just simple data. We had something called as big data. Right now, we're dealing with something called as big data. You would have heard of this terminology being thrown around a lot. Big data, right? Now, we don't just stop with big data. You'll come across certain concepts like data, data lakes and data warehouses. All of these are concepts that are related down to information. Data is power, I'll say at this point. Okay. So you have information with you. Information, which is data, and that too large amount of data. Okay. Now, all this amount of information cannot be processed by us by a group of people because earlier days, what used to happen is they'll go in and put up a company. They'll go in and say, "Yeah, okay, you can go in and they'll give you some data. You just go in and you analyze it and give me a final summary on what I should do." That is what people used to do at that time. But right now, the amount of information that we have is so high or so huge, right? That humans or people cannot just go in and do them normally at this point. And that is where machine learning comes into the picture, right? So machine learning is basically all about going in and much like the word what the word suggests, machine learning, making a machine to go in and learn. A learning is a stage where you go in and you provide it with information. How did you guys learn? Your parents made you to go to school and they bombarded you with, they gave you books and internet and everything, and they made you to learn. So that's the same exact thing. The reason you guys learned was because you were provided with this opportunity to go in and learn things. You were provided with information to go in and process. So that's the same exact thing of what machine learning is all about. You go in and you create models and then you deploy it. And these models are basically able to emulate the same analysis and operations that can be done on large number or large amount of data. And this is exactly where the machine learning engineers will be coming into the picture. Okay. Now, as I said, information can come from anywhere because at this current point of time, we have 5.25 billion active internet users. There are around 1.92 billion websites and a whooping 2.5 quintillion bytes of data is created on a day-to-day basis. So we are generating large information of data. But what can we do with this data? Because all of this data, if I just go in and look at it, I cannot even understand a single word. But that's where data science comes into the picture. If you have enough amount of information, it can be collected, analyzed, and processed such that you can gain really crucial information, which can give you an edge over the competition. The general use case of data science is to solve business problems because businesses have clients and clients have issues. What exactly does the client want? What should be changed so that the client can or the user base can have a better experience? This is what data science is mainly meant for, solving data or business problems, right? So now hearing together, as a saying, see, let's say if I have some, you know, some really big amounts of information. Let's say I have some big data with me, a large amount of data with me, right? So, in when you think in terms of machine learning, right? We machine learning is a really simple idea. You're making a machine to learn, right? So you have different softwares, you have different machines and algorithms that you can use so that the information or the data that you've collected up so far and processed and it's already in and it can be you can take up really useful insights from it. Insight in the sense, the word insight in the sense it's basically the key information which can bring up some change. That's what we call as an insight, right? Some really useful information. So we need to get that insight, and that's where machine learning comes into the picture, right? So ultimately, everything related to data science is meant for ultimately going in and act as a solution for to address business problems. Okay. So now what we'll do is we'll just let me kind of give you a pretty simple roadmap to follow on how you can actually go in and get started with data science. Okay. So that's also what this course is meant for. We'll be helping you guys to go over the various tools that will help you to get your journey started with data science. All right. So I'm gonna give you a five-step process. Okay, I really because it's really simple. See, when once you know how many steps are there, you can easily count how many steps you actually covered or you've taken up till this point, and how many steps are remaining. It gives you a really good context on what direction you're moving towards. Okay. So, as I said, we're going to be discussing this five-step process on how exactly you can go in and get started with data science. So, the very first thing you're going to be doing is to go in and pick up a programming language. Now, one of the reasons this webinar is called Introduction to Programming, so Introduction to Python for Data Science, is because we will be emphasizing everything on Python, right? So we'll be using Python-based tools so as to go in and do all the operations and analysis. Now, it's not just Python that you can use. You can also go with another really popular language, which is called R. Now, Python and R, both of them are dynamically typed languages. What I mean by this is you don't need to specify what type of variable you have created. In Python, you can just go in and write a equal to 10. There you go. You automatically created an integer variable. Even though that integer variable is an object, it's as easy as that. Did I have to specify that that variable is going to be storing an integer value? No, I didn't. It's the same case in case of R as well. R is also a cross-platform, dynamically typed language. So this would be a step number one. Which particular language should you go in and start off with, right? So as we'll be going in and utilizing all of these various libraries, we are going to be going in and starting this off with Python, right? So here we come across our fourth point in our entire roadmap, which is what all tools do we have for Python for data science, all right? So that is our second step. Step number two, you're going to be going in and mastering several computational Python libraries. Python has several libraries that you can utilize, all right? One of the most easiest one I'll say is you can, if you want to try this out, you can use this particular module called as PyTube. PyTube, much like the name suggests, it allows you to go in and perform operations with the YouTube API. You'll be able to write a Python code that can download videos or entire playlist for you within a fraction of a second. Like it'll just take like 3 to 4 lines of code and you're all good to go. Okay. But right now, what do we want to do? I don't want to download videos. Why should I use PyTube? No, I don't want to use PyTube. What you currently want to do is you want the ability to go and analyze information and process them. You want libraries that are fast and efficient. And these are the same two words which basically define both of these modules or Python libraries, and those are NumPy and Pandas, right? So both of these libraries are basically add-ons, so they don't come inbuilt with the Python packages. So you will have to go in and pip install it. So later on, as we go into our sessions, I'll take you through the whole process on how exactly you're going to go in and install NumPy, Pandas, Matplotlib, and how can you even start it off with a project. So we'll be covering up all of this in the upcoming set of days. All right. Now, the main reason why people use NumPy is because you get access to multidimensional arrays. an array, a multi-dimensional array. I'm pretty sure you would have heard of a two-dimensional arrays. A multi-dimensional array basically means the same thing. All right. So, matrices, you can say a two-dimensional arrays are basically just a matrix. They kind of help you out in storing up information and processing them. So I'm not just talking about two-dimensional ones, multi-dimensional arrays and matrices can be generated and manipulated using NumPy, which is the main use case for it. Because the NumPy array is way faster in comparison to the normal Python list that you would come across. Okay. Then we have Pandas, which again is written for data manipulation and analysis. One of the main reasons why Pandas is used is because it has pre-built data structures and operations, which you can use for manipulating the numerical tables that you would have. And like it also one of the main selling points is it also allows you to manipulate time series. Okay. Now, step number one was basically to go in and learn a programming language. In our case, we'll be opting in for Python. Step number two will be to learn or master computational Python libraries. In our case, we'll be going in with NumPy and Pandas. Right. Now, I'm not saying these are the only two libraries that are out there. There are several other libraries that that may be tailor made for your own use case. Okay. The third thing that we want to do is, yeah, so now I went in and I processed a lot of information. Sure, okay. See, but the problem with the human brain is that we don't remember things the way machines do. Machines are capable of remembering information by using this set of ones and zeros, right? Bits, we say. But the human brain is meant to go in and recognize and remember patterns, right? So if I were to basically just go in and show you guys an entire table with all the information on how many COVID cases were there in every other city in the entire world, you may feel like what exactly are we doing with this? Because there will be an insane amount of information that would be over there. So you need to go in and be able to process all this information and manipulate it accordingly. So for that, we have NumPy and Pandas. Sure, we're gonna go in and get this done. But right after this, see, just because I have a lot of information, it's not gonna be that convenient for us to go in and brainstorm over it, right? So that's why, when you have large array of information or large set of information, data visualization can be a really useful tool in that regard. Why am I saying this so? See, understand in this case, when whichever business that you would be working in for, okay, like whatever may be the domain, data visualization will help you to go in and deliver information in the most efficient way as possible. Okay. So what you basically do with this is like data visualization mainly will be dealing with gathering raw data, modeling it, and then delivering the data in such a fashion that you are able to go in and come up with major conclusions at the end. Okay. Now, when you deal with advanced data analytics, right? We have various such algorithms like machine learning algorithms, tons and tons of them, linear regression, logistic regression, so many more, right? But the main reason for why we need data visualization is basically that it helps you to go in and convey information and insights, and you'll be able to go and come with the final conclusion way easier in that manner. All right. So one of the main few selling points of data visualization is that it allows you to go in and get a better agreement because all the information can be easily summarized up, and it would be easier for people to go in and come up with various solutions for the problem in hand. It's obviously a superior method in comparison with that of the traditional strategy, where you just go in and put information in a table and then just pump it out. All right. As all information that we have will be properly analyzed and arranged, we also will be able to go in and share information according to the need. Okay. Now, what all tools do we have? Step number three, right? Okay, we know what data visualization is. We're just going to go in and take the raw data and, make a graphical representation of it. You could say that. Yeah, we're going to go in and make a graphical representation of it so that we are able to easily observe and analyze it. Now, for data visualization, we have two such really popular libraries or header files, which are mainly matplotlib and Seaborn. Okay, so these are two pretty common, libraries, Python libraries that can help you to go in and get some visualization for the data. Okay. Now, our fourth step, all right, the fourth step that we have is machine learning. Okay. Now, machine learning is the idea with machine learning is that now you might want to keep this in mind though. Data science and machine learning, even though are related, are two are they have different functionality and use cases. Okay, so see, this is kind of how the overall schema would look like. Like data science and machine learning, they are closely related. Okay, as you can see in here. But they have different functionality and different goals. Okay, so if I would say like data science is basically the field where you study the approaches to find insights from raw data. Okay, that is what data science is all about. Okay. Now, machine learning is basically a technique that is used by a group of data scientists to enable machines to learn automatically. No need to go in and sit and spoon feed it. It will be able to go in and learn things all on itself, provided it has enough pieces of information. Okay. Right. So, as I said, see, machine learning, if you want to go in and get good at machine learning, there will be various algorithms that you will have to go through. We have linear regression, logistic regression, decision trees, random forest, KNN, naive Bayes, and so many more. Right. So once you go, so because mathematics and linear algebra, all of these concepts are extremely important, so such that you are able to go in and start using up to solve real world problems. Okay, so now, yeah, now let's come down to the very last step. You want to get good at, or you want to go in and get your career started at data science. What do you need? You need projects, and more projects. Okay. So I'll kind of just leave you up people with this small, with this small website that is pretty useful, I'll say, and can help you to go in and, start it off with some one or another data science project. Okay. So, what you could do is you could go in and visit Kaggle. Okay. So, Kaggle is basically this website where you will find tons and tons of data sets to work with. All right. And there are also Jupyter notebooks that are readily available within the platform that you can use to go in and perform operation. It is fairly, it's a pretty, useful website, I'll say, because it will help you out in going in and structuring out your path towards data science. Okay. Now, let's just quickly go in and summarize this. The very first step. Now, we did go through a total 5 steps on how to go in and become a data science, or to basically pursue data science. Step number one would be to go in and select a programming language. It could be either Python or R. Step number two would be to go in and master the computational Python libraries. It could be NumPy or Pandas. And then you have a data visualization tool, which would be Matplotlib and Seaborn. Step number four is machine learning, where, as I said, you are going to be requiring the fundamental knowledge on maths and statistics. Along with that, there will be tons and tons of algorithms which will be helping you to go in and you know um, like processing the information accordingly. Now, for the very last step, as I said, and projects. The more you do, the more projects you do, the better it would be for for your career. Okay. So let's so we'll just so this is the data science for beginners workshop that we'll be conducting in soon enough. Within a few couple of weeks, we'll be starting off this particular workshop, and on a weekly basis, we'll be taking up a few sessions where we'll be going in and discussing the various concepts uh, that will be helpful to you in data science. Okay. So this entire course that has been planned out is for a total of 20 hours. Each day there will be 2 hours worth of sessions that will be, that will be taking up. And what we'll be covering up in these sessions will be we'll be going across all the prerequisite Python modules that will be required for us for data science, which will be NumPy, Pandas, and Matplotlib. So we'll be going across all three of these Python modules so that we can go in and start building up some projects. It'll be 20-hour comprehensive course, and by the end of it, you will be provided with a certification on being able to complete the entire course. And one more thing would be that every single lecture that will be taken from this point onwards will be available 24/7 in the FacePulse YouTube channel. All right. So I'll say that this basically brings us to the end of our bootcamp webinar. I thank everyone for going in and showing up here at this odd time. We had a short delay in the very initial part, but we were still able to go in and pull through. So, if you guys have any queries as in such related to whatever we have discussed up so far, you can put it up in the chat section. Or if you want to reach out to us at any other point in time, you can find me at pony.canute@faceacademy.in. Right. So that would be all from my side, people. Thank you for all the cooperation and showing up. Thank you and good night.